In the next two sections, we'll be solving oblique triangles. An oblique triangle is one in which there is no right angle. So here we have a triangle. It's labeled A, B, and C, and we're using uppercase letters for angles. So here we have angle A, angle B, angle C. Opposite to our angles are our sides, and they're labeled same letters but in lowercase. So here we have side A, which is facing angle A, side B, which is facing angle B, and side C, which is facing angle C. Once again, none of these angles are right angle. In solving oblique triangle, we need at least one side. In addition to that one side, we need two angles. So we could have side A and angle C and angle A. In addition to that one side, we could have the other two sides. So if I have all three sides, it's possible to find all three angles. Or if we have that one side and one other angle and the one other side, we can solve this oblique triangle to find all the sides and all the angles. Now we will look at two rules that allow us to solve these oblique triangles. Here's the first of our two rules that allows us to solve an oblique triangle. It's called the laws of sine, or sometimes the sine rule. And we use this when we have two angles and one side. So here we have an angle side or an angle side angle. We also use it when we have two sides and an opposite angle. So if we have, for example, side A and side C, then our opposite angle would either be angle C or angle B. Here, this is the height of our triangle, and we can find the height by using height is equal to B times the sine of A. So our sine rule is actually A over sine A is equal to B over sine B and C over sine C. An alternative form of this is a reciprocal. Sine A over A is equal to sine B over B, which is equal to sine C over C. We will use any two pairs of these to solve our oblique triangle. So if we're asked to find side C, and we're given angle B and angle C, and side B, then we should be able to find side C, since this is our only unknown. We're going to look at a few examples demonstrating this. Here in this example, we're being asked to use the laws of sine to solve this oblique triangle, and we're being asked to round your answer to two decimal places. We're given that A is equal to 102.4 degrees and angle C is equal to 16.7 degrees, and side A is equal to 21.6 units. When we're solving a triangle, we're trying to find all the sides and all the angles. So here we have two angles already, so we're trying to find angle B, and we have one side, side A, so we're trying to find side B and side C. I've gone ahead and I've drawn our triangle. So here's our angle A, which is 102.4, our angle C, which is 16.7 degrees. We know that in a triangle, the total angle is 180 degrees. So angle A plus angle B plus angle C is equal to 180 degrees. If we know that, then we can subtract angle A and angle C from our total to give us angle B. So here we go. So angle B is equal to 60.9 degrees. So now we have all three angles. Now we're going to find the next two sides. This takes us back to our sine rule. We know that our sine rule says that A over sine A is equal to B over sine B, which is equal to C over sine C. Since we already have A and angle A, and we're given angle C, we could use these two groups to solve for side C. So here we go, we have A, which is 21.6 over sine of 102.4 is equal to C, our unknown, over the sine of 16.7. If we multiply both sides by sine of 16.7, we eliminate this, and this ends up being c is equal to sine of 16.7 times this side, which simplifies to give us 6.36 units to 2 decimal places. To find sine b, we can use a over sine a is equal to b over sine b, since we already know angle b. Once again, if we multiply both sides by sine b, it eliminates sine b on this side, and now we have sine b times a over sine a. So here we go sine b times a over sine a, and this simplifies to give us 19.32 units. So here we have our two additional sides, b and c, and our additional angle b. So once again, we're being asked to use the laws of sine to solve a triangle. We're told to round our answer to 2 decimal places. We're given this time over one angle and 2 sides. And you notice that the angle is opposite to the side. So because in our sine rules, when we're given 2 sides and an angle, one angle needs to be opposite one of the sides. We know from our sine rule that a over sine a is equal to b over sine b. We're already given a, an angle a, and we're given b. So we can solve for angle b. So substituting for a, we have 8 over sine of 36 is equal to b, which is 5 over the sine of b. If we simplify in this by using our cross product, we get the sine of b is equal to 5 times the sine of 36 all over 8. To find angle b, we take the sine inverse or arc sine of all of this, and this comes out to be 21.55 degree. So now we have angle a and angle b. We know the sum of all the angles in a triangle is 180, so now we can find angle c, which will be 180 minus angle a, which is 36, minus angle b, which is 21.55. So angle c is 122.45 degrees. Now that we have angle c, we can proceed to find side c. You can use a over sine a is equal to c over sine c. A would be our 8 over sine c, a which would be 36. If we multiply both sides by sine c, this becomes times sine of 122.45. When we simplify this, we get side c to be 11.49 units. So here we have our additional angles and our additional side.